healthy flamingos. In today's video, we will discuss how healthy muscles generate forces. Whether in whispering a syllable or lifting a heavy weight, we require the coordinated and synchronized use of muscles, and our body has numerous of them for moving our joints. We have various types of muscles in our body, some for involuntary contractions such as the cardiac muscles in our heart, and some for voluntary contractions such as the skeletal muscles. Skeletal muscles can vary widely in sizes and shapes. Some of the most common and larger weight-bearing muscles are those in our limbs, such as the biceps in the arms or the quadriceps in the thighs, more commonly known as the quads. Muscles are composed of fibers that extend from tendon to tendon that connect to our bones. Fibers can vary in sizes depending on the size and type of muscle. The muscle fibers are grouped together into bundles that lie alongside in parallel or in series depending on the size of the muscle. The smallest unit of a fiber is known as a sarcomere, which is responsible for producing the muscular contraction or the smallest unit of force from the fibers. Muscle fibers are innervated by the alpha motor neuron that resides within our spinal cord. Motor neurons will innervate several muscle fibers scattered throughout the muscle and not necessarily the fibers that are just lying next to each other. This type of a distributed innervation ensures that the motor neurons' electrical activity can stimulate the whole muscle globally. The alpha motor neuron and all the fibers that it innervates forms one motor unit. When the alpha motor neuron receives neuronal excitation, it is activated and it will electrically stimulate each of the various fibers it's connected to. Muscle fibers are physiologically compatible with their motor neurons, and therefore larger fibers are connected to larger neurons. The total number of fibers that a neuron is connected to determines its innervation ratio. One important thing is that motor neuron has a one-to-many mapping to its muscle fibers. This means that one motor neuron is connected to many fibers throughout the muscle. This leads to a distributed and a smooth muscle control. On the other hand, each muscle fiber is typically innervated by just one motor neuron in a one-to-one mapping. However, one exception exists in the muscles of our tongue. A motor unit will be activated when the alpha motor unit is electrically stimulated and reaches its action potential. The signal passing down to the fibers causes the muscle fibers to contract, and cumulatively we have a motor unit. Twitch is the building block of the force produced by a muscle. When the motor unit is repeatedly activated, we have continuous bursts of these motor unit twitches, and when the unit is activated faster, the twitches will summate or tetanize to the muscle force. This is the idea behind the muscle force. Each muscle is composed of hundreds of motor units, depending on the size of the muscle. The brain sends the command or neuronal excitation to each of these motor units. With increasing excitation, more and more and larger units are activated. Hence, the force output increases and also smooth out as the twitches summate. If you've enjoyed today's video, please don't forget to subscribe to the Healthy Flamingo for all of our weekly updates, and thank you again for watching. See you next time.